Imagine you want a wall run. You need the character to move up and down, since moving forward will move you into the wall. We need to find the up direction. But how? With the cross product node, we can do just that. I'm currently line tracing using my actor's forward vector, and then tracing down from the actor to hit the ground, or wall I'm standing on. When you use a line trace, you can use something called impact normal to get the direction of the surface the line trace hit. Very useful for this situation. So let me add a cross product and connect the impact normal to A. So now I have the first direction. Let me just quickly add some cylinders to visualize what's going on. So this right here is the direction we get from the impact normal. It's pointing outwards or inwards from the wall. The cross product will take two directions and return the third. So if I input a direction going up, currently being the actor's forward vector, the movement will be towards this cylinder's direction. If I connect B to this direction instead, being the actor's right vector, I'll now get the up direction. I'm using the colors to represent each direction. Green being Y, blue being Z, yellow indicating the impact normal. So now I got the up and down direction, but it's flipped. When I move forward, the character is going down instead of up. So imagine the direction going this way. You can always flip the equation to get the opposite result. So essentially, the cross product will take two directions and return the third. Since there's only three directions, X, Y, and Z, inputting two of these will always return a third. You might be thinking, if I input two directions, can't I just guess what the third one is? Yes, in theory. But that's only when the answer is straightforward. For example, in this scenario, you can guess that the answer is Z. But what if the directions are rotated differently? Then it becomes much more difficult to predict the exact number. Also, you don't only care about the axis, but the value as well, since you can either have a positive value or a negative value. I will explain this further in a minute. But first, let's dive deeper into how the cross product works. First, it's important to understand the basics of vector math. A vector is just a number along X, Y, or Z. The important thing to understand is that a vector can be used in many different ways. For this video, we just need to know that it can either be a location or a direction. For example, X equals 5 and Y equals 5. This could be a location in your world, but it can also be a direction. So how can we tell the difference? Like I said, it's about how we use it. For instance, if you set your actor's location to X5 and Y5, the actor will be placed at that location. If you were to move your actor towards X5 and Y5, you would take your actor's current location and move it along that direction. A direction vector is usually normalized. So since we only care about the direction when using it for this purpose, we don't need to know that X is 5 and Y is 5. We just need to know that it's more than 0. Normalizing these values will shorten them and make them more accurate when used as a direction. There's also a nice trick where we can turn two locations into a direction. Let's say that A is 5 on X and Y, and B is 3 on X and 1 on Y. If we subtract A from B like this, X minus X and Y minus Y, we will get these numbers. If we try to move from A to B using these numbers, it won't work. But watch what happens when we try to go from B to A. 1, 2 on X. 1, 2, 3, 4 on Y. This result can also be used as a direction pointing from B to A. If we subtract B from A, we will get the opposite direction. So now that you know that, a cross product will not work properly with locations, but rather with directions. So the actor's forward vector, for example, is already normalized and will return a value from -1 to 1 along the X or Y axis, depending on its rotation. If X equals 1, and on B we use a direction that equals 1 on Y, we will get 1 on the Z as well. If we change direction and set X to -1 and Y to -1, the Z will also return in the opposite direction. Keep in mind that I'm only showing X and Y for demonstration purposes. You can input any axis, so Z and Y, for example. But what if X equals 1 and Y equals -1? Or Y equals 1 and X equals -1? In order to determine what direction the result will be, The cross product follows something called the right-hand rule. Stick your hand out like this and point your index finger straight. Your index finger is A. Take your middle finger and point it up. This is B. Stick your thumb out straight. The direction of your thumb is the cross product result. Even if you turn your hand, the result will always be perpendicular to A and B. So the next time you show someone the finger, just tell them you're doing math. If you want to flip the direction of the result, you can either change the equation, like setting x from 1 to -1, for example. Or you can change the order of A and B. Earlier, I said that we don't always need to know the direction, but the value as well. For example, let's say that I want to do a cross product to find out if the enemy is on my character's left side or right side relative to where I'm looking. You'll need to cast to the enemy to get a reference. What we can do here is to cross product our character's forward vector and combine it with the location trick I showed you earlier. The direction doesn't actually matter right now because we're going to use the result to let us know whether the enemy's on the right side or left side. Now you'll see that when the enemy is on my left side, it's a positive value. Right side, negative value. If we flip the direction, it will be the opposite. We can also normalize the result since we only need to know if it's positive or negative. So how exactly does the cross product give us the result? The red line is my actor's forward vector, and also A. The green line is the location direction, or B. The result is the blue line on Z, which will either face up or down, depending on which side the enemy's on. We don't need the Z direction to do anything, just to give us the positive or negative value. If I were to face the exact same direction as B, the result would be 0, and it wouldn't work. This is true whenever you use cross product. So the cross product is a very situational node to use. It can be used for a lot of different stuff, but most commonly it is used if you want the perpendicular direction to A and B. I have shown you 2 different ways you can use it, but it can also be used to calculate torque, finding the rotation axis between 2 vectors, and especially when you're dealing with angles or slopes.